Let's think about area integrals. So the first thing I'm going to do is to calculate the area of a square using integration. So let's think about a square living in the xy plane. We'll put one corner at the origin and then it extends out to a distance L in each of x and y. The way I'm going to do it is I'm going to divide this square into many infinitesimally small squares. And each individual one of those squares has an area which is delta x, delta y, the width in x and the width in y of those very tiny squares. So the total area is then the sum over that large number of tiny little squares of their individual areas, delta x, delta y. Now I could choose to add them up in any way I want, but the way I'm going to choose to do it is to, first of all, sum, for example, all of these guys down here at the bottom that lie at the same value of y, and I'm going to sum in x. So the crucial thing here is that my first sum is going to be done at fixed y, and I'm going to sum in x. So, if I come over here, I find that my total area, well, I'm going to do it at fixed y, so delta y is going to be the same for all of these squares. I just bring it out the front, and now I do a summation in x, and we know a trick for doing summation, which is to integrate. So I integrate from 0 to L, the range in x, dx. And the integral dx of 1 is just x, evaluated between 0 and L. This is just L. Now what I'm going to do is I'm going to add up, so this of course was the area of the strip. What I'm now going to do is I'm going to add up all of those strips as I move in the y direction. So now I'm going to do an integral from 0 to L in y. Here L is just a number, so it doesn't participate in the integration, and again the integral dy is y, between 0 and L gives me L, and so I get L squared as the answer, which of course we know is the correct area of the square. Of course I could have chosen to have done my sum my squares in a different way. I could have done that first by doing the y integration first and then adding those strips in the x direction, and that would have given me the same answer. So I could have done the x and the y integration in the other